Hi guys, this video covers some applications of queues. The previous video described the queue abstract data type. Before we get into how it works, we want to describe what we use it for. So there are actually plenty of direct applications of queues. You might remember back when we covered stacks, it was kind of hard to come up with some examples. I had to grasp at straws a little bit. But for queues, there's actually plenty. Any user visible feature in software that has a first in, first out queue, in other words, a fair line where people go in at the back and come out at the front, would correspond to a queue data structure in software. For example, the YouTube video player has a play queue. So you add videos to the back of the queue and you watch from the front of the queue. When you finish watching a video, that front video goes away and whatever was in second place now takes over the first place spot and we watch that video. Spotify, the music player, also has a queue to queue up songs to listen to in the same FIFO order. The Netflix DVD rental service has a queue. You can go in and put DVDs into your queue and it picks the next video at the front of the queue. Video games have this, like StarCraft. You have factories that can build things, and they have a queue to stack up multiple constructions in order, and it uses the same FIFO queue. So there's a lot of these examples. We could go on and on. I bet all of us have used some software that has a literal queue in it. So I think we can all relate to how the queue data structure is useful in software. Just to give you a little bit more flavor, there are some computing applications besides literal queues. One example is a message queue. This is something that is built into operating systems, so this is more of an operating systems course topic beyond the scope of our data structures class. But the point of a message queue is it's a queue of messages that are sent from one program to another. Those messages are basically strings that could contain anything. So this is a mechanism for one program running on your computer to send a message to another program. And the operating system kernel keeps an internal queue of these messages so that the messages get transmitted in the order that they're sent. This is one way of describing inter-process communication, or IPC. It's a way for one process or program on a computer to communicate with another to implement features that we care about. For example, copy pasting between different programs could be implemented this way. One program that copies could send a message to the program that receives the paste, and that's how the information could get from one program to another doing a copy paste. Another application is the command queue built into the OpenGL graphics API. This is really a computer graphics topic. Again, we're not going to get into detail in this in our data structures course, but it's just so you know some other applications of queues. OpenGL is an API for real-time three-dimensional graphics, namely video games. It's mostly for video games, but it is used for other applications that have graphics that are video game-like. And an OpenGL command is one function call that deals with one task involved in creating graphics. So in order to render one frame of a video game, there would probably be thousands of OpenGL commands that say to draw lots of triangles and place lights in certain locations and things like that. A C++ program usually sends commands to the GPU. The GPU is the video card hardware built into the computer, and the OpenGL API handles the details of that communication between the host and the GPU. Ordinarily, we use something like the painter's algorithm, which says that the order of drawing matters. You need to draw things backward to front. So it's important that the commands that are sent execute in the order that they are intended to be sent. For example, we have the Mona Lisa over here, and the painter's algorithm would say you should paint the river first and then paint the face of the portrait, because if you paint the face of the portrait and then the river will go over the person's face. And, you know, the way that things work in real life is that you see the nearer objects, they occlude the further away objects. So you don't see the river, you see the face because the face is closer. So a queue is a way of managing that, making sure that the commands that are issued from the graphics program, like the game written in C++, actually get rendered in the order that they should get rendered. Another example is breadth first search. This is another algorithm for traversing a graph. Our previous video on stacks introduced the idea of depth first search, DFS. This is breadth first search, BFS. And they're similar algorithms, but they work a little bit differently. This is, again, kind of an advanced data structures topic or an algorithms topic. We're not ready to go into the details of this right now, but it is an alternative to depth first search. And both of those algorithms, DFS and BFS, use a data structure to keep track of the vertices or the circles that have not been explored yet. And basically, depth first search uses a stack for those, breadth first search uses a queue for those, and there's some trade-offs between those two things.